we knew that we were both kind of in the intersection of developer and enterprise. And we're asking ourselves, what's still hard to do? And we went back and looked at, all the different things, and access control was immediately something that we noticed. Well, there's an API for that for everything except for access control, right? And why is that true? Let's go back to, our work at Microsoft and try to figure out why that's true and why that could be something that we could go after. Access control is in the critical path of every application request.
You're listening to the Enterprise Ready podcast, a show aiming to change the enterprise software narrative, how to sell to enterprises to how to build for enterprises. We'll interview industry experts and enterprise software founders as we break through the jargon, establish a common vernacular, and share the lessons learned from building the world's best enterprise software. Hi, I'm Grant Miller, creator of Enterprise Ready and founder and CEO of Replicated, where we enable cloud-native software vendors like HashiCorp, CircleCI, Sneak, and many others to operationalize and scale the distribution of their modern on-prem applications. Check us out at replicated.com. The Enterprise Ready podcast is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. If you're interested in being a guest on the show, or if you'd like to suggest a topic, or just learn more about enterprise features, find us at enterpriseready.io.
In this episode of the Enterprise Ready podcast, Grant sits down with Omri Gazitt, CEO and co-founder of Aserto, an opinionated framework that provides everything necessary to build enterprise-ready, role-based access control. The two begin with a dive into Omri's early beginnings in enterprise software, including his time at Microsoft working on the .NET framework. This sparks a discussion into the challenges of building interoperable software and how the software buying motion changed during the 1990s. The conversation shifts to Omri's time running the XML team at Microsoft and the lessons learned that would lead to the creation of Azure, including building the team and bridging the world of enterprise for what would inevitably become known as the cloud. The pair then cover a multitude of topics, including a multi-vendor versus single-vendor approach to open source ecosystems and how managing complexity for heterogeneous enterprise environments is key. Finally, Omri discusses what led him to found Aserto, as enterprise-grade access control was something that large organizations still clearly struggled with. All that and much, much more in this new episode of the Enterprise Ready podcast. Many thanks to Omri for his time, and we hope you enjoy.
All right, Omri, thank you so much for joining.
Thank you for having me.
Well, let's dive right in. Tell us a bit about how you got into enterprise software and how you've been building things.
Yeah, the enterprise. Let's see. This goes back a little over 30 years, so I may be a little bit older than some of your typical guests. But right out of college, I was going to go back to Israel. That's where I'm from. That's where I grew up. And I think I was about 20 years old, and I was going to do a summer working for basically whoever paid me the most money. And at the time, I did my college in Houston. That was Texaco. Texaco had an information technology department. So I think it was like $13 an hour, which was like the most that they would offer anybody for a summer job, which was great because I wanted to save a little bit of money before going back. And so, as a kind of basically an intern, I was trying to figure out what I was going to do. And they sold me on all this development that I was going to do. Anyway, I joined this place and they have like all these mainframes. And I'm like, okay, what do you want me to do? They have like these logs that they want me to transfer. I'm like, okay, I'll go right in and see. They're like, see, yeah, we don't have that on the mainframe. I'm like, what do you have? I was like, we have COBOL, we have PL1, we have, well, if you're a really crack programmer, BAL, basic assembler. And I'm like, how about C? So I went off on this kind of like a scavenger hunt. And I found a C compiler on their, system 370 or whatever. And I started building this thing. And I just recall, it was just such a shock because they didn't think I would get it done. They thought it would take the whole summer. It took me 3 days. And I was like, now what? They're like, okay, now you have to rewrite it in PL1. I'm like, what? It works. And they're like, yeah, but we don't know how to maintain it. No one here knows C.
Nor will they ever learn it.
Exactly. That's right. Yeah. It was a funny introduction because on the one hand, I'm like, this is completely night and day. Like what I learned in college kind of has, very little bearing in terms of like what the quote state of the art is for enterprises at the time. It was kind of an interesting lesson, that kind of follows throughout my career. Sometimes it's easy to forget that, when we live on kind of like the bleeding edge of technology, larger companies take much longer time horizon to adopt those technologies. So I was like wrong point in time, but I was right directionally. Because 5 or 10 years later, of course, all the stuff that we were doing, Unix systems at the time and, the PC revolution and all that stuff was going to, go disrupt, how those folks did business. So inside of the cocoon, like they had no idea like that all this stuff was about to come, so I could see it. But at the same time, I realized that I had to be a lot more patient in terms of how I thought about the time horizons for enterprises.
Yeah, I mean, nothing happens in 3 days, it's too short. And so after that, so that was, like what else? I know you were at Microsoft for a long time, a handful of other, real deep enterprise companies. Like, tell us about those experiences.
So I guess before, as it turns out at Texaco, I met this guy who was a founder and, we didn't have the term startup at the time or things like that or founding an engineer, but he basically said, hey, instead of going back to Israel, why don't you join me and we'll do a startup together? And so I said, that sounds kind of interesting. Let's go do that. And as it turns out, I met him in the Texaco building. His quid pro quo was they gave him office space and mainframe time and all sorts of stuff like that. And in exchange, he basically agreed to supply them a perpetual free license of whatever was going to come out of Neon Systems. And it was pretty interesting because I was mostly interested in the engineering at the time. But I learned from him, how it is that you go talk to enterprises and understand what their pain points are and what their requirements are. And we knew that we wanted to create something that was basically kind of the bridge between like this new world of client server. Microsoft was building like all these, new applications like Access and Visual Basic. And there's an entire industry that had these data hungry applications. But enterprises wanted to connect them to, kind of their enterprise data sources. So, mainframes, DB2s, IMS, and Unix systems like Oracle and Sybase and so on and so forth. So, that was a pretty interesting formative experience because I was kind of employee number one. And we went 6 years with that and we eventually took it public.
Wow.
Back in 1999. So that I call my rose color tour through startupdom. But one of the things I learned through that was that we were at the right place at the right time. We were right at the bleeding edge of this, kind of like this disruptive wave that was hitting enterprises. And, all of them needed what we were building. And the disruptive wave was brought about by Microsoft's kind of new platform, this client server platform. And so, like back at, in 1998, 1999, Microsoft called me up. I think it was 98. Yeah. And they said, hey, we're building this new, this new platform, what eventually became .NET. Do you want to come join us? And that was like, I could not say no to that because it was so fascinating to see like this platform wave that floated a lot of boats, including ours, back in the early and mid 90s. And Microsoft was about to do the same thing. And so I was one of the first 10 people that, got to work on .NET.
Oh, interesting. Okay. And I mean, so talk about .NET, like what made it so interesting and new, like for the uninitiated, like what's special about it? Or what was unique at the time?
Sure. Like at the time, basically Microsoft it was kind of like the number 1, 2, and 3 software vendor, but it was pretty clear that the cracks were showing. Like Sun had started out Java around 1996 and, the browser was becoming the platform. And Microsoft was trying to figure out how to fit into this new world. And so it was very clear that software architecture was changing. You basically need to invest a lot more in how to build web applications. Microsoft was pretty good at, kind of like designing systems that enterprise developers could use, like Visual Basic or Access, where you would basically have kind of like an interesting, like today we call it low code environments. An interesting environment that was kind of like restricted in some ways. It wasn't like you couldn't do everything and anything. You didn't need to understand what the Windows message loop was. But at the same time, you could actually build, interesting and powerful applications if you had this opinionated framework. And, at the time, we also were trying to grow up market, right? So we were considered the, like the client side company, operating system, what have you. And T was trying to, kind of get its bona fides in the enterprise. And I recall like first joining and, I really needed at Microsoft. It was very easy as somebody who was in engineering and product to like not talk to customers at all. But one of the things I used to do is every summer I'd go fly out to Wall Street and meet with a bunch of banks over there. And, it was just really humbling because they're like, oh, Microsoft. Yeah, you guys make mice, right? Like, you guys don't make enterprise software. We're like, oh, we made this thing called SQL Server. And they're like, toy. And you're trying to figure out what they were looking for. And, it just ended up being, there's a combination of reputation and, feature set and, kind of like basically meeting them where they were. So a lot of them were like, look, we would take you more seriously if you built tools for Java, or we would take you more seriously if you ran your database on Solaris, or, kind of the operating systems that we have. And it was a really interesting, kind of set of decisions we had to make because on the one hand, we knew that nobody loved us on Java and nobody loved us on Unix. And on the other hand, we had to kind of figure out how to meet our customers where they were. And so really .NET was about creating something that could be an alternative to Java. But we knew that we could never grow it on the middle tier, like as a middle tier application server type of framework. And we couldn't really win the database unless we, kind of took steps to interoperate with kind of like the world of IBM and BEA and Sun and Oracle and all those things. And so we basically had to change the game. And one of the things that we realized could happen is there's this new kind of like the web protocols were going to become a lot more important than all these binary, kind of like point-to-point protocols that like the Unix world and the Java world had. And so we basically started out by, kind of creating this web services, consortium. And we had our competitors there, IBM and BEA and Oracle and Sun. We all tried to kind of build software that interoperated. And for us, it was a way to level the playing field. When a enterprise came in and said, hey, are you Java compliant? We're like, no, that's not the right question to ask. The right question to ask is, do we support SOAP or WSDL or UDDI or some of these early attempts at like web interoperability?
Interesting. I mean, so this is like it's a very different world than we live today, where I think most people think about Microsoft, and the success that they've had in the enterprise and, almost as if they are, clearly there's a consumer side to Microsoft and a small business side to Microsoft, but the enterprise side seems incredibly successful. So, this is a time period when Microsoft didn't have that credibility.
That's exactly right. And we knew at some level that this was a game of patience, right? So we had a few people that had come from the enterprise. We had the person who ended up running the SQL Server division came from basically a healthcare company. And he could tell us as a customer what, we needed and, what we needed to do in order to be enterprise credible. And for a company that was so engineering centric, it was really hard to hear, but ultimately kind of the desire to win, overcomes your biases and your almost chauvinism, right? And so we ended up, kind of like eating some humble pie and realizing what we needed to do in order to get more credibility in the enterprise. So some of the things, some of it is like features, right? Like SQL Server didn't have, I think it was row level locking, and then when we delivered that in SQL Server 7, all of a sudden, like SAP said, okay, now we can actually go build our software to finally run against your database. And so figuring out what the unlocks were, like whether they were features or whether they were, kind of support contracts. Like, for example, people wanted, support like for 10 years and our speed of innovation was much faster than that. But we had to kind of learn how to, extend our support cycles and offer extended support for a lot of money in order to actually match the enterprise requirements.
Yeah, and this is like you mentioned something which is like SAP being like, okay, now we can have our ERP talk to your database as the back end, which is, I think, a pretty foreign concept to many people today, right? Like, you don't have applications that are like, oh, we can run on Oracle or run on, I guess SAP eventually built HANA for some of their tools to run on, or run on, SQL Server or Microsoft SQL. Like, what? Do you have context as like why that was the case? Like, is it because you had a special DBA? Is it because there was a shared system? Like, why were people running applications that way?
Oh, fantastic question, because it's actually one of the patterns that I think, led me and Gert to start Aserto. And, we'll get there eventually. But back in the early 90s, these business applications would basically bring their own database, right? Like, you would basically embed something like Oracle or DB2 or maybe SQL Server, and you'd bring it along with you, and you would pay a royalty to the database vendor. And towards the late 90s and definitely early 2000s, the whole buying motion changed, right? So there was, enterprises basically said, we have a site license, an ELA, for DB2 Enterprise Edition or for Oracle Enterprise Edition. And typically the larger the enterprise, they'd have 2 or 3 of these. And they'd have these heads of architecture that would decide, what it is that they supported and what it is that they didn't support. And to your point, it was exactly that expertise, the expertise of, DBAs, system administrators. They wanted to make sure that they had, a smaller, like a constrained number of enterprise-ready infrastructure that they could support. And so basically the burden became, shifted to the application provider to run on top of that infrastructure. So, if you supported Windows NT and supported, these, Unixes or this Linux, the application provider had to actually go meet those requirements. Now, on the one hand, it made it a little bit easier because you didn't have to pay a royalty, and to bring something embedded. But on the other hand, it required basically interoperability standards to get built. And I use that term in a very loose way, right? So for example, POSIX was a great interoperability mechanism, because back at Neon, when we were asked to go port our software to a bunch of different Unixes, DEC Unix and, Siemens Nixdorf, in Germany had like these Unix systems. They all kind of supported more or less the same system call APIs. And some of them even had application binary interfaces. And in the database world, it was ODBC. ODBC was the thing that basically flattened that whole space. So before ODBC, every one of these databases had their own call level interface. And so we had this n times m problem, right? Like, you had n applications trying to talk to n different databases. And it was like the Cartesian product of all of those in order to get the interoperability going. And what ODBC did, and later on JDBC and some of these other things, was to make that an n plus m problem, right? Like, so if the applications could write to a single API, and all of the database vendors had drivers for that API, all of a sudden you're making this problem a lot more tractable. And so, one of the patterns that we see here is for you to actually, for that platform shift to happen, there has to be some interoperability mechanism that enables that.
Okay. And did someone write the spec for what an ODBC? Uh-huh. Did someone write the spec for that? Like, how did that kind of standard become available?
Yeah. So Microsoft basically wrote a book on it, like, wrote the spec, the API. And then they were really good at running these DevCons early on. And so they had, their strength was the ISV ecosystem that they brought from Windows.
Right.
And they had to evangelize it. They had to have a critical mass of database vendors that were willing to play ball. And companies like Neon, we basically built our entire business connecting, all these data hungry applications with these enterprise data sources by building, to this ODBC spec and making it like building all these enterprise features around it. So, that was basically how Microsoft bootstrapped that. And once you get to a critical mass or a tipping point, then that becomes the standard. And
right.
Sun basically copied that. They basically said, okay, well, we need one of these for Java and we're going to make it pure Java. And so they were able to parlay some of that initial work and even use kind of like the same, like letters, the same, kind of acronym.
Sure.
And, to essentially bring that same capability to the Java ecosystem.
And that was a JDBC.
Exactly.
Got it. Okay. And so did it mirror some of the patterns, and was it sort of like a similar inspired spec?
It was. I mean, I think more in name than anything else. They try to bring the Java kind of sensibilities, the patterns, the opinionated, way of designing APIs to the Java world. But the pattern, like at a 50,000 foot level, the pattern was so, kind of recognizable that it was relatively straightforward for all these companies that built ODBC drivers to then build JDBC drivers. And so, kind of the next, like that was, your move, son, right? Like they actually, kind of were able to parlay, the work that Microsoft did into their own ecosystem. And Microsoft had to respond by saying, okay, we're going to change the game yet again and make it not about Java, but we're going to make it about open standards on the web. And the early versions of those were like of, SOAP and WSDL and UDDI and then WS star, like, some of them failed miserably. And, I have maybe the distinction of being the manager of all of those things at Microsoft. But eventually we got the rest, and we got to things like OpenID Connect, and we got to things like, JWT and SAML and things that, and OAuth 2, things that to this day are kind of like how the web does security and identity, for example.
Yeah, but along the way, you had to do some XML, right?
Oh, yes. Lots and lots of XML. Oh, yeah. It's funny because I think it was one of the SVPs at Microsoft kind of looks at me and a few of the other people. I ran the XML team at Microsoft, and He looks at me and he goes, "We're all going to hell for what you've done to this industry."
I mean, the crazy part is, right? Like you introduce like a new interesting pattern, a way to, kind of like organize data that's machine readable. It's not perfect the first time, right? Like the reality is a lot of these things aren't perfect the first time. And, but it's like, it's good enough that it worked and it still is powering many of these things, right? And so, I think what's interesting is the idea like, hey, eventually we revisit it and we redo it in a way that's a little more efficient and a little different, and, take some of the lessons that we learned, but we wouldn't have learned those lessons had it not existed in the first place.
Exactly. I mean, it's a great lesson around iteration. And at Microsoft, if anything, I would say our iteration speed or learning speed was way too long. We were kind of bitten by the bug of trying to make it perfect. And, as we all know, perfect is the enemy of good enough sometimes. So, that's one thing that, I would say in retrospect, we spent so much time trying to get these things right that we got them wrong because we forgot to go work with folks like Google and eBay and Amazon and Yahoo, who were all kind of who were all consumers of this technology, whether they were building on top of Linux or, their own custom systems or Java or .NET. In the meantime, they were like, this stuff is way too complicated. We're just going to try to go do some of our own things. And they started talking to each other. And all of a sudden we realized the power in this industry is no longer with the platform vendors. The power in this industry has shifted to these companies that are building mass scale internet services. And that was like an enormous lesson. That's actually one of the things that ended up leading to Azure.
Interesting. I mean, we'll talk about that.
Yeah. So I think it was 2005 or 2006, we kind of realized that there were early signs. Like, one of the things I used to talk about was, okay, so we built this platform. Now what? Like, let's start building some patterns on top. And so I proposed this service to Bob Muglia, who was was the president of the server and tools business at the time, which became the Azure team, right? And I said, how about we create these storage bricks, and like basically have these REST or, SOAP APIs for being able to like, kind of push and pull data out of, kind of like our big hard drives, because MSN, and Bing and Live and all these services, they have these like enormous data centers. And he's like, that's the stupidest effing thing I've ever heard. Like he was like, do you know how much it costs to actually move a gigabyte of data, over the internet? Like it's faster to actually put it on a DVD and send it like FedEx. is faster and cheaper. And I'm like, yeah, but, like project a few years out. And of course, by the next year, Amazon had S3 out, and it was pretty clear that it was doing EC2. And so we were, I would say we woke up around 2006, 2007 to this. And so we started building a team, putting a team together. And some of the things were obvious, like you had to build a hypervisor, you had to build a, kind of a storage system, you had to build the moral equivalent of EC2. But I was really interested in how it was that you bridged between the world of the enterprise and the world of what we now call the cloud, right? Because it felt like we had one foot in each camp, right? We had all these high scale, mass scale services, on the, kind of like MSN live side. And then we had increasing know-how in the enterprise. And so what we set out to do was build stuff like, that could like bring together the world of on-premises and the world of the cloud. And the first service was what we call the Azure Access Control Service. And famous last words, this is part of the inspiration that led to Aserto. But we had services like, for example, the service bus, where like connectivity between on-premise and off-premise was really hard. So you had to kind of figure out ways to relay the traffic. And that was actually very valuable. So how do you actually have, kind of like some, code running in the cloud that could go talk to an enterprise system kind of behind the firewall, so to speak, and be able to get data out of an enterprise system. That was the service bus.
Sure.
And then, the access control service was what became the Azure Active Directory.
Okay. So, the service bus, was it a product that you sold, or was it like a part of the overall platform still? Like, how did you think about introducing some of this functionality?
Yeah. So like Microsoft's really good at packaging, right? Yeah. So one of the things that Microsoft did, historically, very infamously was it said, oh yeah, we have this thing Word, we have this thing Excel, we have this thing Access, and each one of them competes with a different product. What we're going to do is we're going to sell Office. And, Office is going to be at basically the price of one of these products, but we're going to sell you all four. And we have a suite. And the very first, version of Office literally had no integration between these products. It had none. It was like, actually, it was a box, like back when we used to buy software in boxes. Sure, it had Word, and then a coupon for Excel and a coupon for Access. It was like that bad, right? But the business model was very sound. And so Microsoft knew that we had to go package all this stuff up. On the one hand, we needed to have consumption-based pricing and licensing for each one of these services, which we experimented with. And on the other hand, we kind of knew that we had to go, kind of like be able to package them up as an offer together. And, from 2008, when we first launched the first version of Azure up until now, it's come an enormous way. Like at first we were just stumbling in the dark, not even knowing who our customer was. We first got, kind of like confused, and we said, okay, we want to compete with Amazon and go after the startups. And then we started talking to startups, and they're like, why on earth would I use your thing? My VC tells me that if I use anything for Microsoft, they will not fund my next round. Like, it's as simple as that. Like, I don't care if it's free. I will never use your thing. And so we realized, okay, well, that's probably not the audience. There's, over time, we want to kind of build better signal value for Microsoft in that community. But we have to kind of find other people who are a lot more amenable to, what we have to offer here.
That's funny. Yeah. I still have the experience of like trying to sign up for like, an Azure account and realizing I have to like create a Microsoft account. And I'm like, well, I don't really want another email address. I'm like, I just want to sign in with like my granitereplicated.com email address, not like create a on Microsoft.com account in order to access it. And it's like, I'm like, it's just funny to me that they still to this day seem to want to control the identity layer. But by doing so, they end up like, with their emails going to some email address that I'll never check, right? It's like this sort of an interesting, anyway, it's sort of an interesting side there. So the Azure piece here, realizing that your customers were not the startups, but were actually enterprises that had, and users that were deep into the Microsoft ecosystem, and then embracing that, I guess.
Exactly. So, if you back to Bob, who was, by the way, in full disclosure, an investor in Aserto as well. He was the CEO of Snowflake before they ended up going public. But he basically said, we have this thing, we used to call them workloads, right, at Microsoft. Like, so we had the app server workload, which I ran, we had the database workload, we had the file and print workload, and then we had the identity and access workload. And he always used to say, this is the linchpin workload for Windows Server. Why? Because every server application needs to know who is logged in and what they can do. And they get that information out of Active Directory. And Active Directory had like upwards of 90%, probably 95% market share of the identity and access workload. And it also spoke LDAP, which was the other main protocol. And so, kind of like the thought experiment was, what does identity and access look like in the age of SaaS and cloud? Like, you had all these kind of early versions of SaaS applications, enterprise B2B SaaS applications, like Salesforce and Workday and ServiceNow and all these folks. And they had to go build login on their own. There was no operating system to ask who was logged in.
Right.
And they also needed to go invent their own access control mechanisms. And so the irony is we thought about access control as being kind of like the really important problem, and we started building that. And then at some point we heard from people that like, we don't even know how to log in. So we're like, okay, well, we got to solve that first. Login is actually kind of like comes before. So we set out to go build, what eventually became, like I call it the interoperable identity fabric. So, you have things like OAuth 2, protocols like OAuth 2 that allow you to, now use an identity provider that you're not necessarily running, right? So Google can be an identity provider, Facebook can be an identity provider, Microsoft, Amazon, and so on and so forth. And, that saves you from having to, like, that's the N times M problem again, right? Mm-hmm. And then, like 10 years ago, you had, Auth0 and Okta, and none of these companies existed, right? But they saw this opportunity to, kind of leverage some of these emerging standards and build enterprise single sign-on. So no one has to go build this thing that doesn't want to anymore, right? Like, you now have developer APIs for developers, and you have enterprise systems, like for enterprises that make it simple to solve the enterprise single sign-on problem. And access control is a problem that, like we still have to this day. We'll talk about that, I'm sure, a little bit later on. But that was kind of what we set out to do with Azure Active Directory. And we obviously tackled the identity part first, but knowing that we were very strong on Active Directory, and we were trying to figure out how to parlay that into a service that would be essential in the new cloud.
Yeah, it's interesting. Yeah, and I do want to, we will return here because I think let's just hit a couple of these other experiences, the stuff you did at HPE and Puppet, and then let's dive into, what you're doing now at Aserto. And if you want to mention any, I know you kind of like had some other startups and things that you did along the way, and, some other roles, but, those two seem to be the most kind of like pronounced in your career recently.
Yeah. I left Microsoft in 2011 because I was frustrated that we didn't get open source. I'd always been in dev tech, and Microsoft absolutely got, kind of Intel, and IBM, and this kind of like basically the standard hardware. And then it was a little late, but it got the internet. It like basically Bill turned the whole company around in 1996 and said, this thing is going to be the thing.
Right.
And in 2001, 2002 is no longer kind of as involved. And I remember at the time, Microsoft was super confused about open source. It said there's a cancer, this is going to kill the rest of the industry. And even at the time at Microsoft, you'd ask questions like, so, we have this web server called IIS, and there's this thing called Apache, and we don't really have any differentiation. In fact, we're a little behind it right now with its latest architecture. We can invest 50 people over the next year to go close those gaps, or we could just adopt that thing, because it's kind of commodity now. And people would look at us like we were like from Mars, and they'd say, "Oh, you're in the F Windows business. I got it." And you'd be like, "What?" I mean, like, no, we have to own the whole stack, right? So when you're Microsoft and you're just such a successful company and you've gotten away for so long with building everything, it's simple to assume that you can continue to build everything, and that's kind of the right strategy. And I think by 2011, things were starting to thaw out, but I was ready to actually go try my own thing. I wanted to go back to startup land, built a consumer startup, ran into the ground after a year. The biggest learning there was, and I'm not a consumer guy, I'm a B2B guy. And so I ended up being in the startup ecosystem.
It's so appealing though, right? The whole consumer world, you're like, I got this idea, I know how to build shit, I'll get this thing done, no big deal. People will love it. And then you're like, why doesn't this work?
So, just a 30-second aside, when I first started back at Neon, this was in 1992, I asked Peter why he got to what he was building. And he said, look, two kinds of startups you can do. You can do a consumer startup or a B2B startup. We didn't use those terms, but that's what he meant.
Yeah.
And he said there are only 10 companies that actually build software that is sold to consumers. Microsoft's one of them, and I think Quicken was another one, or Intuit or what have you. There were a very small number, and he's like, it's just basically it's a very short head and a very long tail of startup carcasses.
Sure.
By contrast, there are a lot more viable businesses that can sell to sell B2B. And I remember when I first started to build Steady, all my advisors were like, what are you doing? Like, you have all this knowledge and platforms and cloud and all that stuff. Why don't you just leverage that? But I had a consumer itch to scratch, so I had to go do that.
Yeah, sometimes you just got to go try something, right? You got to go off and see if you can do it, and you're like consumed by an idea, so you might as well. I get it.
Exactly. So I ended up finding myself, after kind of like being in the startup ecosystem for a little bit in the early 2010s, HP called and said, hey, we're starting this cloud division. Well, we have one, but we're now starting to get serious about it. And I said, HP, are you guys still around as a vendor? They're like, yeah, all the jokes. But Meg really wants to go build this cloud thing. And she's looking for people who are really good at it that could be, available. And I had a few friends that had already ended up there. So I ended up joining to run engineering for the cloud division in Seattle. And the thing that really brought me there was open source. So by the time, when I left Microsoft, I was obviously building with open source, but this was an opportunity to actually kind of get a better sense of how open source was built. We wanted to become part of that ecosystem, what was OpenStack at the time. And then this was a little before the Cloud Foundry Foundation was formed, but I wanted to steer us towards an open source path for application, kind of our PaaS strategy as well. And here was a company that didn't have any of the bugs that Microsoft had. They were not confused about who they were. They realized that they were primarily a hardware company and that they had been, kind of like the distribution channel for Microsoft and for Red Hat and for, all these other vendors that sold operating systems. And they kind of decided that, they were going to try to get in the game by using open source and becoming part of an open source community and contributing back, which was very attractive because that was learning I didn't have, obviously, in Microsoft.
And so talk a bit about the OpenStack community just in general. I think it's really fascinating, sort of parallel, particularly because we've covered Kubernetes a lot on this podcast. So,
yep.
Interesting to sort of hear your perspective around how, some of the lessons from OpenStack were applied into the Kubernetes ecosystem and, what was learned there and what kind of went wrong.
Yeah. So OpenStack kind of started out as this, experiment between Rackspace and I think it was NASA. They basically said, hey, let's go create, Rackspace needed to go build something that looked like AWS. And they kind of decided to go build something together. I think each of them contributed one thing. And it's been a long time, but, the compute project was called Nova. And then there was a storage project called Cinder. And, and all of a sudden, the open source ecosystem started coalescing around this. There were a bunch of MySQL developers that were just coming off of the Sun acquisition by Oracle, getting disillusioned. There were just a few people that started getting really interested in what would open source look like if we were trying to build a cloud control plane. And I would say that project ended up, it was started out by practitioners, but enterprises ended up dominating it pretty quickly. So you had IBM move in, you had HP move in, you had Red Hat move in, and, all of a sudden it became kind of like this, like this political system where on the one hand, the engineers were trying to kind of hold on and, keep control of the project. On the other hand, you had these large enterprises with a lot of interest in it.
Was it the vendors or is it the sort of the...
Exactly. The vendors basically, kind of took over a lot of the governance, and there was still a technical advisory board. But there was also no, kind of guiding hand, so to speak. There's no center of gravity. So you had all these different projects, and they had different leaders. And it was kind of like this loose federation. You could think of it as the decentralized, model for open source. And that was in contrast to the BDFL kind of model of the benevolent dictator for life kind of model. And they were pretty, explicit about saying, we're trying this out. Like, we don't know if it's going to work or not. And as it turned out, like, the project kind of fell over because it tried to expand too much, too fast. And these pieces didn't really relate to each other very well architecturally. And so when I think about Kubernetes, I think about like the center of gravity was always Kubernetes, right? Mm-hmm. Like the CNCF now is this sprawling thing, but there was this center of gravity, this anchor tenant that really, provided like a lot of the design patterns. If you look at something like Crossplane, for example, they borrow the Kubernetes API, CRDs, the Kubernetes machinery. So there are a lot of patterns to build on top of. Whereas I would say with OpenStack, there just wasn't enough of a core to try to build around. And so, there was a lot of hype early on. OpenStack was, I think 6,000, 7,000, 8,000 people conferences, twice a year. Yeah. And there were a lot of customers and users that tried to build on top of it and got to like, tens of thousands or hundreds of thousands of cores on the system. But ultimately, I think that it just kind of crumbled, under its own weight.
Right. I mean, I think it's actually still has success in the world where it's running at all these telcos and powering all these data centers. It just didn't become the platform that like we write software for, right? It's sort of like could be under the hood, but no one really knows about it. And it's not really become a primitive that like, is really enabling developers or application builders or SREs or anyone else to like, build applications. It's sort of like maybe it's running some, some infrastructure at large telcos around the globe.
Exactly. And that was actually one of the decisions that we deferred for a long time and we eventually had to make, as part of the OpenStack steering, committee. There was always this kind of like dichotomy of, are we building stuff for, smaller companies, for startups, or are we building stuff for larger enterprises? And given the fact that big vendors were involved that were all selling to larger enterprises, the larger enterprise agenda won. And as it turned out, the vertical that was most eager, like that was basically needed its own transformation, was the telco vertical. Right. They were all going from proprietary hardware, software systems. They all wanted to go to open systems. And so that was this use case that found the most purchase with OpenStack. And so more and more of the community's efforts were diverted towards building these higher end telco features, things that were like, deep down in the Linux kernel, kind of like architectures that would allow real time kernels to run, architectures that would allow kind of direct memory, swaps instead of like a bunch of copying between kernel and user. There's just a lot of DPDK, was one of the things I remember, like one of the features that we're trying to deliver, all sorts of integration with, kind of networking things like Open Daylight. And there's just like, that was the agenda for the community because those were the customers and the customers basically lead you.
Sure.
Whereas I would say Kubernetes had not really succumbed to that, like until much, much later. I think it was hellbent on creating what OpenStack wanted to become, right? Like the substrate that for the cloud.
Right.
And then after it was able to kind of create this, the win broadly, when at the breadth, it started moving up market.
Yeah, and I think, there's probably a bunch of lessons you've seen, but like one that I think was taken directly from the OpenStack community was around conformance testing, right? And so to call it Kubernetes, it has to pass pretty extensive conformance testing, and so there's just not the variance between different providers that I think maybe you saw in the OpenStack community.
Right. I mean, if you think about the APIs for OpenStack, they were all common, but every vendor of, let's say you had a kind of some storage thing that you wanted to go build, a Cinder driver for, you'd go build it and then you'd expose all your features. And so this wasn't a write once, run anywhere kind of thing. Like these were, all basically thin shims on top of, kind of like hardware that wanted to expose itself to the world. Whereas I think a lot of the things that in the Kubernetes world, like Rook, for example, that's a software solution. And there are kind of things that plug into it. But I think that there's a lot more commonality, to your point, so that you have a very consistent experience, no matter like what you're running it on top of. The other big learning, I would say, is that OpenStack had no adoption from the large cloud vendors, right? Like Microsoft wouldn't give it a time of day. Amazon certainly didn't. Google didn't. And so you basically didn't have you had no pull from that. The largest vendors that did have OpenStack based systems were the second tier, like HP and IBM and Rackspace. And that was just not enough nodes. That was just not enough public cloud infrastructure to make a difference. Whereas I think with Kubernetes, you had Google as your anchor tenant, right? Yeah. And pretty quickly, Microsoft saw an opportunity there. And then eventually, I think Amazon got there too. But, when you have 2 out of the 3 large hyperscale public cloud vendors, that are on that architecture, you've already crossed the tipping point, I think. Yeah.
And then, so let's kind of briefly go into your time at Puppet, and then let's talk about Aserto.
Yeah, so Puppet was, a lot of fun because it was kind of right in the middle. I'd done startups, I'd done large companies. Puppet was 500 people. And, on the one hand, it had a good brand with DevOps. On the other hand, it was pretty clear that its value proposition was getting, disrupted with containers and with the cloud. And when I first got there, the what if, or the kinds of questions that I was asking was do we want to be Puppet for the cloud? And people were like, well, what do you mean? I said, well, when I look around, I see things like Terraform kind of being Puppet for the cloud. That's what Mitchell tell you. Like he set out to build Puppet for the cloud. And it was kind of a hard transition because I think Puppet at that point was so focused on its customers, specifically, folks that were, large companies that were standing up lots of infrastructure, tens or hundreds of thousands of nodes. It was very focused on its knitting, which was try to make it as simple as possible to manage configuration, on all these systems. The physical to virtual machine transition was super simple. That was really easy. The move to containerization and to microservices was much more of a head scratcher. And so we spent time, I basically, when I first arrived there, 100% of the engineering and product effort were focused on the, kind of the software that we had. And, part of the process there was to start, kind of transitioning more and more and more of our innovation, of our engineering and product effort to working on this new world. And some of it was just even experiencing the new world, starting to, Dockerize our stuff, starting to run our stuff in Kubernetes. Sure. At some point, we started working with you guys at Replicated to take some of our, software and, kind of make it, be able to transition it, run it, in different places.
Modernize it, running Kubernetes in customer environments. Yeah.
Exactly. And so, that was I would say I underestimated kind of how much of a transformation that would need to be. But one of the biggest things I learned there was about really writing a product that had its own open source ecosystem. There were kind of 3 models, there's obviously the closed model, and then there was this open source model, but you were a single vendor. And then there was this multi-vendor open source ecosystem model. So we tried that latter, with OpenStack and later on Kubernetes, and Docker was a little bit like that. And Puppet and Chef were more of the single vendor ecosystem.
HashiCorp, yeah.
Exactly. HashiCorp is a great example of one that is as well. And I wouldn't say that one is better than the other, because I used to say, well, multi-vendor open source ecosystems tend to win out over closed, or over single vendor ones. But that's not obvious, right? Like, I think HashiCorp has won in some where they had a clear, value proposition that no one else was doing. Like, I think Terraform is a great example of that. And, in other places, I think the multi-vendor approach got to scale faster. And, I would say that, like, there's still people that use Nomad and love it, but Kubernetes is definitely the thing that won that generation.
Sure.
So with Puppet, some of it was about, like, how do you actually look at the new world? And some of it was, what do people actually pay us money for? So the conventional wisdom was, people want an enterprise product and enterprise support. Well, what does that mean exactly? And so you start digging in a little bit, and some customers will tell you, well, I don't pay you for all of the, agents that I run on my Linux nodes, even though those are 99%, or between Linux and Windows, 99% of my infrastructure is that. I pay you for the 1% that run on Solaris or AIX or Z systems. I don't even have Z systems anymore, but just the fact that you have that available makes me feel like you have the breadth to be able to support me, because I'm a snowflake and I have snowflakey types of requirements. And so, like, you may have like less than 1% of your overall node count may be on a particular platform, but your most, kind of loyal customers are valuing you for that. So that's a pretty interesting product.
Yeah.
That's a trade-off. Like, do you actually support a long tail, even though you know that there are hardly any people who use it? But on the flip side, it gives you that credibility with those enterprises.
Yeah, and it's sort of it's almost like scarcity creates value to some extent as well, because it's kind of like, well, this is the only way that I know how to do this, and the fact that you continue to do this means that, like, there's no competition there, but I want to have standard tooling, and so, like, it's kind of like I need you to continue to do that in order for me to continue to use the tool. Makes sense. I mean, and especially when you think about, I was talking about, like, the idea that, like, enterprises, like, add new technologies on, but they don't necessarily drop, like, old technologies at the same rate. And so it's like kind of an expanding pool. They do drop some occasionally, but, like, I think there's more adding than there is subtracting. It's kind of like laws in the same sense, right? There's a lot more laws that are added to the books every year than are taken off. And so you need tools that continue to manage all of that. And, a lot of what enterprise software does is help end customers manage the complexity of years of sort of legacy tooling, or old operating systems, old, like, apps, old systems, just like, because that's what you need to do. You need to manage a lot of complexity.
Exactly. And that is ultimately, enterprises pay you for manageability. They live in just a sea of technology, to your point. And the level of complexity of trying to manage that, kind of heterogeneous environment is staggering. And that's what they spend, a huge chunk of their IT budget trying to do. And so anything that helps them make that morass more manageable, I think, is very attractive to them. One of the things that, like, speaking of RBAC, that's one of the most obvious things that people, kind of paid for when it came to Puppet, right? So Puppet was a great single, workstation tool. And as soon as you try to make it work for teams, so, like, scale up both in terms of the number of nodes as well as the number of people involved, that was where I would say the interesting monetization opportunities were. And, Puppet didn't really get its open source strategy right at all. If you have Luke on your show, Luke Knies, the founder of Puppet, he'll be the first to tell you that.
I mean, it's hard because they were one of the first vendors out there doing it well, and there wasn't necessarily, GitLab and, I mean, even Puppet today. Like, many of these other companies that have figured it out better today. It's like, it's just what the model wasn't as clear. Like, the commercial open source model was like everyone pointed at Red Hat, and that was about it. But there's more ways to do it.
Yeah, exactly. And Luke would say, back then, what was emerging was this open core model, right? Where, it kind of made sense for databases. Like, so MongoDB, for example, had, an open core, and then they would build features around it. And for Puppet, there was this interesting architecture where the tool gave you value running it on your own workstation, Puppet Apply, right? And it had the same exact interfaces, basically the same DSL, domain specific language for authoring your, all of your modules and things like that. But as soon as you started wanting to manage fleets of things, you needed, what was back then called a Puppet Master, So that was also open source. Like basically Puppet decided to open source everything, the server, and the client. Mm-hmm. And Luke would say that was, a critical error because that brain, that orchestrator was the thing that actually provided the scale for the system. Yeah. And enterprises tend to pay for scale. And so companies like Apple and Google had like literally hundreds of thousands of Puppet nodes running and weren't paying Puppet a cent because the open source software was good enough. And some of the specific scaling points, things like RBAC and other things, they just kind of built point solutions for. So one of the biggest learnings he had, and I've adopted that as well, is, he calls it the open edge model, where everything at the edge is open source. So anything that an application interacts with or a developer interacts with has to be open. The engine is open, but the brain, the control plane, is something where you can actually add a lot of value and therefore, build a real value proposition that you can sell.
Yeah. So let's dive into Aserto. So one, let's talk about, the inspiration for it. We talked, years ago as you were thinking about it. And so, excited to hear kind of how you tell the story today, and let's talk about what the product does, and let's talk more about RBAC too, because I think, what it means and what it is. So, but let's start with the founding story.
Sure. So, again, back to the, 2007, days where we were me and my co-founder were both working on what became Azure Active Directory. And the idea was, try to reimagine what Active Directory would look like in the age of SaaS and cloud. And that meant identity and access. And when Gert and I, kind of popped our heads up around summer of 2020, we're like, okay, it's time to do something new, time to do a startup. We knew that we were both kind of in the intersection of developer and enterprise and cloud maybe. And we're asking ourselves, what's still hard to do? And we went back and looked at, all the different things, and access control was immediately something that we noticed. Well, there's an API for that for everything except for access control, right? And why is that true? Let's go back to, our work at Microsoft and try to figure out why that's true and why that could be something that we could go after. And, we immediately kind of picked up on the fact that it was a much harder architectural problem than, let's say, standing up a service that does, text messaging or payments or email or even authentication. Most of those are one and done, right? They're not in the critical path of your application. You want a payment to go through, and when you get a 201 back from your, REST call, you want to know that you're going to get paid, but your app is not waiting for that, right? Whereas authorization, access control, is in the critical path of every application request. So it has to run close to the application. And that's why the state of the art is libraries in a bunch of different languages. And it's, every one of them is different. There are a bunch of different patterns. It's all a cacophony. Node.js has its things, and Golang has its things, and, in Python has its things. And it's just, there's no leverage, no reuse. It's just all, a bunch of spaghetti code strewn across your application. So you really want a service, but you want it to have the operational characteristics of a library. You want it to be 100% available to you, not 99.99% available, but 100% available. Because if the authorizer is not up, then your application's down, right? And you want it to be very, very fast. And so we realized it needed a hybrid architecture. And that was kind of a new thing. You don't really see developer APIs that have that very often, where you have a component that runs right next to your application. And then you have, basically a control plane that runs in the cloud. And if you look at the Kubernetes, architecture, it kind of gives you words now to describe what that is. We have a word called sidecar, that basically is a container that runs in the same pod as you. And so there's a why now aspect to this where I think, architecturally, the cloud native world has evolved to the point where we can now talk about these hybrid architectures as something that you don't have to go reinvent a whole bunch of stuff. You could, layer on top of existing patterns. And, then we, of course, did the requisite, talked to 100 CTOs and VPs of engineering and asked them about problems they have and specifically about access control. And, 98% of them basically came back and said, big problem. I have to build right now. It costs me a lot of money to build and maintain. It's not really core to what I do as a business, but I have to get it right if I want to go sell into larger customers. And so we start asking them, so how often do you rebuild these things? And they're like, yeah, every year and a half, like I have to go back to the well and put a team of 3 or 4 people on it. And they have to they think it's going to take them 2 months, but it actually takes 6 months. And there's just like an enormous opportunity cost around that. So we definitely saw that pattern of developer API, that there was room for. And, at that point, it was a matter of, can we build this? And so we started looking around. And again, we're big believers in open source and open ecosystems. We found, obviously, OPA in the CNCF that looked to be an interesting engine to try to build around and on top of.
The open policy agent, right?
Open policy agent, exactly. And so, we didn't see a whole lot of other people doing it, but the ones that were kind of inventing their own languages and their own, building their own engines. And we thought that was actually going to be a distraction. Instead of doing that, which we know how to do, but, it's undifferentiated heavy lifting from our perspective. Go find a common engine and go solve the architecture problem. How to bring data to that engine in a way that's like that engine can operate in, hundreds of microseconds or maybe a very small number of milliseconds, so it's operating on cached data and solve that synchronization problem. How do you bring data to that engine? How do you bring user information to that engine so that it has it cached locally? How do you bring resource data to that engine? Those seem to be the hardest problems. And so that's what we ended up setting out to solve.
So the position is it's actually the hardest part isn't like how to describe the policy. It's more like how do you actually implement this in a way that's hyper efficient and fast.
Exactly. Because if you are, like just an enterprise that's walking up to OPA and saying, okay, I want to go build on top of this. All the hard problems are still there, right? Like you certainly have to learn a language, and you have to learn how to interact with that particular component.
And the language, you mean Rego, is that right?
Rego, exactly.
Yeah.
But, the hardest parts are really how do you build a distributed system that allows you to gather all this data that the authorization engine needs to make an authorization decision, as opposed to having the authorization engine go make a bunch of REST calls to a bunch of systems. And, like those could be, across the internet for all you know. And those will give you a very rough experience if that authorization service is in the critical path of every application request. So, I think there's a hard engineering problem here. And if you see the need, which is every single B2B application has to solve this problem, and the kind of cloud native technologies are just like by themselves, they're insufficient to be able to address it properly. We saw a pretty big opportunity.
Sure. I mean, not just every B2B application, but every application that's internal to enterprises, right? Like you're writing an internal tool or some creating something, like you need to have different roles that people can use and leverage in order to decide who has what permissions, right? So it's sort of based on that principle of least privilege, right? Is that kind of a security principle in a sense?
Yes.
We talk about this on the Enterprise Ready site. Like it was always a core feature of enterprise readiness, right, for software companies is to, have good role-based access control where you're identifying and saying, look, someone that signs up, I can assign them the role of, sales person. And that salesperson is going to have different permissions and access than someone with the role of, engineer and someone with the role of support. And so all these different roles. And, you think about it as even like groups, right? Like, what's the language that you use or define? Because there's clearly like resources, which are the actual things that you're acting on. There's actors. Like what are the words that you use to describe these different sort of key components or players in role-based access control?
Yeah, so we basically start, kind of with the authorizer, right? The authorizer is a thing that takes some inputs and produces an output. And the inputs are what we call the user context. So, whether that's a machine or a particular user, you kind of have to know in the context of who you're evaluating this authorization decision. There's the resource context, which is basically, kind of like how fine-grained you want to take it. So some people say, well, every, kind of like resource in this project needs to be managed in the same way. Some people say, well, every document in this folder needs to have its own, authorization. So you can take it as coarse-grained or fine-grained as you want. And then finally, there's what I would call the authorization policy, right? So the set of rules that allow the authorizer to reason about this user context and resource context and make decisions. And that's the output. The output is a decision. So typically the decision would be to allow or deny access to that particular resource. But you can basically build other types of decisions as well. So one of the patterns that we heard about early on was, well, there's my API and I want to basically have allow deny decisions based on user context and resource context. But then I have like my UI, I have a React app and I want to actually, control whether I'm rendering like a set of controls, like a set of components, or making them enabled or disabled based on the user context. And it's all spaghetti right now, right? Like there's no relationship between these. And one of the early realizations that we made was we could define not just an allow decision, but also a visible decision and an enable decision. And so have a single policy that drives not just API, authorization, but also some behavior on the client. And those are kind of some of the convergence points, I would say, that kind of make people start like kind of imagining what's possible.
Interesting. And so, and like, what, where's the product? How far along? What's the status?
Yeah, so we launched a private beta back in June, and we had a set of folks that worked with us as design partners, and a few of those are now customers. So we just last month we basically opened up our doors. So now we're in open beta. We have production level customers that are running on it. So beta is more the sense of our APIs are still evolving. So we haven't kind of cut the 1.0. On the APIs yet. It's a little bit like HashiCorp, who, has had like 0.xyz, types of releases on things, because I think, Mitchell and Armin are, like they think that 1.0 means something, right? And so we do too. Sure. But at the same time, we're working with a fair number of really interesting customers at pretty large scale points, I would say, to be able to, kind of essentially build authorization into their SaaS solutions.
Cool. And so, who's evaluating it? Is it a developer? Is it a product manager? Like who's sort of the ideal customer?
So typically it's some combination of developers that are trying to figure out, kind of like, I need to go solve this problem. It'll typically be a staff software engineer. And then, oftentimes it has to involve, always has to involve like a head of engineering, a VP of engineering or a CTO. And so, that's kind of an interesting bottom up versus top down type of dynamic there, because you need to have a champion, right? You need to have someone who like recognizes that they want help on this problem. And oftentimes, the three drivers are, it's going to be way more expensive for us to build it ourselves, or it's going to take way more time for us to build it ourselves, but almost always includes, and these folks know a lot more about building a secure solution than we do. And so it's been a very interesting journey because, as we've gotten case studies, like customer evidence, our customers basically tell us, well, like we did the evaluation and we decided that the ROI was 20x better to use your thing, which was like, maybe we're leaving some money on the table.
All good early products do so.
Exactly. But even more importantly, I think it's, you guys think about the end to end. You think about like, you help us design what a good authorization model looks like, all the way to, what the audit trails need to look like so that we can sell our stuff into enterprises. And I think that's a critical piece, right? Because every startup wants to grow up to be able to sell into larger and larger companies. Especially OSS startups, right? Like where, if you look at Puppet, we had, 40,000 organizations using Puppet, about 1,100 of those were customers, and probably, the top 20 paid for 95% of, our salaries, right? So, you have to have, those, larger companies that are betting the farm on you. And in order to do that, you have to meet like this pretty big Excel spreadsheet of requirements. And at the very top of those, will be things like, you need to be able to allow me to run it on-prem, right? You know about that. And, right near that top, maybe even, neck and neck with that is you need to be able to, kind of like work with my roles and permissions. You need to have, allow me to build custom roles. Every decision that your, software makes has to be, need to be like auditable, and, I need to be able to push that into my, SIEM system, my Splunk or my Elk or whatever it is. So there are pretty significant requirements. And when you start adding all those up, you start realizing this is not just like designing what viewer and editor and admin and those roles do. There's just like a whole set of machinery here that must be there in order to be able to close that sale.
Yeah. I mean, that it for sure is the whole thesis of, the enterprise ready piece is like looking at those, vendor security questionnaires and realizing like, hey, there's a whole standard set of features that everyone needs to have. And that was the impetus. And, I think it's great to see services like Aserto out there now that help folks get there faster. Because, like we're all building these sort of non-differentiating, like features that are kind of table stakes, right? And everyone's reinventing the wheel every time. And there's actually big advantages if we can standardize on how to describe those policies, because then you can leverage policies across, different applications, or you can centralize policy management on the enterprise side. So there's a whole bunch of different reasons why, standards are actually really important. And I like that you sort of, have focused on OPA and Rego from that perspective, because I think like, having those standard ways to describe these things is really foundational.
Yeah, I couldn't agree more. And going back to that N times M and transforming that into an N plus M problem, that really, I think, is why we're so excited about this space. Because if you think about the life of an IT administrator today, they live in dozens, if not hundreds of different console experiences. Every one of them exposes a different set of permissions, rolls them up into a different set of roles, has different processes for how to map between what you, the enterprise IT administrator, think of as a salesperson and what they call a salesperson. And, so misconfigurations are rampant. People leave and they still have entitlements. It's a nightmare for the CISO. It's a nightmare for, the IT department. It's terrible, right? And so enterprises have this big incentive to try to standardize, right? And if you think about like the conversation we had about databases, like a little while ago, the same pattern's going to end up emerging here, where in the same way that I as an enterprise wanted to standardize on a small number of enterprise databases, I as an enterprise now want to, standardize on my enterprise SSO and also my enterprise access control plane, right? Like I want to be able to define, like for all my users, all these different types of, roles or groups or what have you, and be able to map them into all of these applications, both internal and external applications, right? So, and that you only get when you actually start getting to standardization. And standardization is not something that one vendor does, right? It's, I would say it's a wave that floats a bunch of boats. And so we're at the very, very infancy of that. And I think that we're going to obviously compete with a set of people that will want to go build things that are similar to what we're building. But just as critical is for us to figure out how to cooperate and build a broader ecosystem so that we can kind of bring about this convergence.
Yeah, I mean, even if there are 3 or 4 competing standards in a sense, it's better that there's standards versus like 5,000 different bespoke ways of doing this, right? And so, if you think about, I mean, this applies everywhere. It's like, hey, look, it's better that there's some standards, even if there's a couple competing ones, that's better than none. And everything's just, completely custom and bespoke and not reusable, so not standardized. So, even if it doesn't end up being consolidated completely or totally interoperable, like something towards a handful of interoperable systems is better than, completely bespoke ones.
Exactly. I mean, a good example is you still see access tokens that are, SAML. And you also have, JWT is, most of the new applications are using that. And it's fine to have to, and it's just kind of like the tax we all pay, so to speak. But it would not work if there were like 2,000, right?
Right. Exactly. Yeah. When you think about building a product like this, what are things you're applying from your previous experiences? I mean, you've kind of been so deep in, in Microsoft, HPE, Puppet, what lessons are you applying to make sure you don't make some similar mistakes? I guess is the first question.
Yeah. So one thing I would say is really kind of understand what problems your prospective customers really have. I think that it's so easy to go and kind of build stuff, and if you build it, they will come. But kind of really getting a lot deeper into what it is that is really problematic for them, where it is that you need to be able to meet them where they are, as opposed to have to like invent things that they have to go adopt. And then where do you actually add value? So for us, like we had that, early conversation around, do we want to go build an authorization engine? And my co-founder, Gert, who's just a titan of technology, he helped build the storage engine for SQL Server and, he was chief architect at Hulu and, wrote the first lines of code on Azure Active Directory. We had the team that we could go assemble to go build an engine, but we realized that that wasn't the place where, we were going to get the most bang for the buck. And instead, people were really asking to solve things that seemed much more pedestrian, but were actually much more practical. Like, well, all our users come from like Okta or Auth0 or Azure Active Directory. And so how do I actually get my, user information into your system? We're like, well, let's go build a directory. Let's go make, kind of like connectors into all these things. Architecturally, let's make them plug-in points so that people can build other ones. We don't have to build them all. Let's go standardize on what a user looks like so that, there's like, again, n times m to n plus m. And then let's go figure out like the protocols necessary to take, all of that information that's collected by the control plane and push it down to, the sidecar, the open source authorizer that we have. That's one hard one lesson, I would say. And another one is really kind of thinking deeply about where you want to be open, where you want to be able to provide an open source solution, and where you think you actually add value, where, even though some people are asking you, well, if you open source this, I'd use this, is that really the right thing for the business long term? And so we're very clear with people. We say the edge, the open source, the authorizer is open source. It's built on top of OPA. We basically build a set of capabilities around it that make it much more valuable to you in the application authorization scenario. And you're free to use that, in the same way that you're free to use Puppet on a single node. But if you want a control plane that kind of helps you manage all that complexity, and solves hard problems like mutual authentication, mutual TLS between, the clients and the servers, having a satellite, what we call a satellite and edge authorizer become managed, all the audit trails and centralizing all of those. Well, that's what we've built in terms of value. And, you can run that on-prem if you want, but that's the thing that, is not open source. And that's the thing that you pay us money for.
Cool. That makes sense. It also seems like you took some lessons around team building and sort of like how you put this together. So talk a bit about like, how you think about growing the team and scaling out and, going to market, or the whole, spectrum of sort of early company activities.
Yeah, I mean, 0 to 1's really hard. And I would say in some ways, it doesn't matter how much experience you have, it's still pretty darn hard. The first thing that you need is a great partner. And so I found that with Gert, obviously. I mean, this is our 4th rodeo together. We're together at Microsoft, then at HP, then at Puppet, and now with Aserto. So, we don't agree on everything, but we have a pretty good shorthand for how it is that, and a lot of trust in terms of how we resolve conflict and issues. And I think the initial team, knowing that we had something pretty, like engineering intensive to go build, we knew that we needed to hire engineers. And we were fortunate that we had a pretty good network, and including a team that we had worked with in Romania of just phenomenal engineers that we acquired into HP. And then, I brought them on board at Puppet. And now, some of them have chosen to join us as well. So this is, again, our third rodeo together. So having a team that has a fair amount of trust built is important. And at the same time, you don't want everybody to think the same way. So you want to kind of you want to seek diversity, right? So, the notion of kind of going out of our first, like in second order circles, but really trying to attract other people that can bring different perspectives. That's easier said than done, right? Like you have to kind of get your name out there, and there's a little bit of a chicken and egg. We were fortunate that some people found us and some people got introduced to us that ended up being great fits. So the other thing I'd say is we were born during the pandemic, and any kind of old-fashioned ideas about being co-located were like pretty obviously not going to carry to the future. I recall having developed a pretty strong sensibility around you kind of either want to be co-located or you want to be remote first. Yeah. There's not really any room in the middle, because if you have half the team kind of like remote and then the other half of the team kind of hangs out by the water cooler, it creates this kind of information asymmetry that's really difficult to overcome. And so we're a fully remote team. We do have obviously a set of people, clusters, a cluster in Timișoara in Romania, a cluster in Seattle, a couple of people in California, a couple of people in Indiana. But everything that we do online. And so I think that has been important from a cultural perspective.
Yeah, no, I totally agree. It's funny, our VP of engineering and our CFO are both in Austin, where I'm located, and a handful of other folks are VP of marketing or VP of, but those two are my direct reports. And I don't see them in person, maybe more than I see anyone else on the executive team in person. Because it's just like, that's just the culture is like, hey, we only get together really in line because that's how we, and when we do get together in person, we're all going to do a little on-site together somewhere. So,
Yep. Yeah, I'd say one other lesson, that I can think of is the lesson of humility. I would say earlier in my career, I thought I knew a lot more of the answers than I did. And, as you kind of put more years, into this business, you realize the only thing, that's common is I don't know anything.
Sure.
And, every situation is different, and you kind of need to approach it from first principles. Some of your experience is going to be useful to bring to bear, because you've seen some things that have worked and some things that have failed. Just because it failed before doesn't mean it won't work again, and vice versa. So, I think having that, like the curiosity and the willingness to be able to fail and learn and fail again and eventually succeed, I think is just one of the critical attributes that we look for in people. Oftentimes when people come in and say, oh yeah, I've done this. I know what phase you're in. I know how to do this and all that. It's a little bit of a turnoff because I'd say this is the first time we're doing an authorization startup. Like there's a bunch of things to learn. I did a startup back in 1992 to 1998. Doing a startup now is like literally there's almost nothing in common between what we did then and what we're doing now. And so having that approaching every day with, humility and, kind of the curiosity and wonder, I think is really important.
Yeah, I love that. I mean, that's a core value for us as well. And I think to your point, like no one's ever built a company like this in 2022. This is the first time that's ever happened. And so, there's a bunch of new things and different considerations that you have to take into effect. And it's, you have to think about everything is like, hey, we're going to try and experiment and try to, leverage some of our experience to make good decisions. But like, hey, we can be wrong and we're wrong a lot. And that's okay. We just try to be more correct faster. And the idea of humility and curiosity really do pair well together, because I think, someone told me that they were like, yeah, well, it makes sense because only really curious people, have a sense of humility, because they know the reason you're curious is because you can't be right about everything. You don't have all the information. You know that you want to learn and there's room to learn. And so, those two values really, really pair up well.
Yeah, for sure.
Cool. Omri, this is a great talk. It's so much interesting experience to dig into. And thank you for sharing. Like, you're like one of those people that I love talking to about like a prior generation of software, because I just learned so much. And I'm like, oh, that's, because generally a lot of the reasons why things are the way they are today is because there is some precedent that was set, prior. And so you can actually learn a lot about why things are the way they are today by just like trying to understand how they got that way in the first place and what was happening before. And sometimes, it was the right decision and sometimes it wasn't. So thank you.
Yeah, thank you. I mean, always a pleasure to talk to you as well. You're such a great, conversation partner and, listener. And I love your perspective because one of the things I've learned in my career is that, never kind of assume that because something happened in a particular way, it's going to happen the same way again. And so having, just breadth of perspective is just so valuable. And I always find our conversations a great give and take because I always learn so much when we talk. So I really appreciate it.
It's two ways. So I love that. Thank you, Omri.
Awesome. Thank you so much.
That's all we have time for today. If you're interested in being a guest on this show, or if you'd like to suggest a topic, or just to learn more about enterprise features, find us at enterpriseready.io. To learn more about Heavybit, visit heavybit.com to check out the library. It's packed with amazing talks on sales, marketing, product, and general management from founders of developer tools companies and other industry leaders. This podcast is also brought to you by my company, Replicated, where we enable cloud-native software vendors like HashiCorp, CircleCI, Sneak, and many others to operationalize and scale the distribution of their modern on-prem applications to their largest enterprise customers. Check us out at replicated.com.